Today we start matrices. Matrices is a plural for matrix. We should probably go on a field trip and watch a movie, right? Yeah. But I heard the English field trip didn't go so well. So. This is a matrix. It's just numbers in a box. Okay? Except we don't call them numbers. We call them elements. Ooh. And every matrix has rows and columns. We would say that this matrix has 2 rows and 3 columns. They're often used to organize data. So the data that I organized in that first matrix might actually be 3x plus 2y equals 1, 5x plus 8y equals -3. Sometimes in these ones with the equal sign there, sometimes people draw a straight line in the matrix to sort of represent that equal sign. And so once again, you see that what a matrix is doing is it's, as long as your x's are lined up in one column, your y's are lined up in another column, and your numbers are in another column, then the matrix allows you to write just a little bit less than the equation was, right? I mean, if you, compare this to English, the amount of things that we wrote here would be probably equivalent to a quarter of a sentence, and we reduce it to about a sixth of a sentence to be much more efficient, which is good, right? Because we don't want to write too many sentences. So we can organize data with a matrix. So we're going to go through some definitions today. Right, the horizontal are called the rows, the vertical entries are the columns, and the first thing that we have to do is talk about the size or the dimensions of a matrix. So we call the size of the matrix an M by N, M rows, N columns. And the way that I remember this is I just think that matrices rock. Rows first and then columns next. So if I had this matrix, it has 3 rows across and 4 columns. The dimensions of that matrix would be a 3 by 4 because matrices rock. Rows first and columns next. Okay? Pretty straightforward. Dimensions will become very important for us. The dimensions is sometimes called the order. I think one of the things that matrices likes to do is use a whole bunch of words to describe the same thing, but not necessarily make it any difficult. Okay, can you write the order or the dimensions of those 3? I'll show the answers in a second. Are we done? Are we ready? Did you get 3 by 1? 4 by 3? 1 by 4. So you do the rows first, which is going across. I always remember columns because I think of like Greek buildings with columns and those things go up and down. To remember which one's my rows, which one's my columns. So we use capital letters to describe matrices and little letters to describe the elements inside. And when we describe those little letters, we write A and then 2 numbers, the I and the J. The I represents which row it's in, the J represents which column it's in. Sometimes there's a comma, but if there's just two numbers, mathematicians go, we don't need the comma. We can be a little bit lazy here and cut it down. So we've got this as the matrix A. We use a capital A to represent the matrix. Then each element in there, A11, A12, A13, A. This one is in row 2, column 1, A22. This one here would be in row 3, column 3, so it's A33. And you can skip the comma if you want. This is considered the main diagonal of your matrix. So I'll give you a 5-second head start. Can you write down what, if that is capital M matrix, what is element M13? M34, M24. And what's the order of that matrix? How'd you do? M13? 0. M34, here I'll circle it, right? Row 1, column 3. M34, row 3, column 4. Ooh, we got the number E. And finally, M24, that should be pi. What's the size of this one? Matrices rock, rows first, 3 by 4. After doing your AP calculus exam, I know this is probably really intense. So do we need a moment just to like take in what we've learned? Or are we good to move on? More definitions. We call a column matrix a matrix with one column. And a row matrix, a matrix with one row. And there are square matrices. Square matrices have the same number of rows and columns. So here we have a square matrix. It's a 1 by 1. Here we have a 2 by 2. Here we have a 3 by 3. And here we have a 4 by 4. A zero matrix. Yes, question.
Could the 4 of a 1 by 1 also be a column matrix or a row matrix?
Yes, it's like the super, it's column row square matrix. Yes. A zero matrix is a box full of zeros. So if you have a whole bunch of zeros in a matrix, it is a zero matrix. Look at this notation. It is here's the notation for it. 0 that's bolded as our zero matrix. And then the identity matrix. For matrices, the identity matrix is like the number 1. If your main diagonal is all ones, you have an identity matrix. Now we learn all these definitions and they seem a little bit crazy and silly, but things will come up later which become very important, and the identity matrix is one of the most important matrices. It's a square matrix. Main diagonal is 1. The transpose of a matrix is just deciding I want my rows to be columns and my columns to be rows. So if row 1, here I'll circle it in green, here's row 1, it becomes my column 1. Here's row 2, it becomes my column 2. And if you do that to every single element, you get the transpose matrix. So try G. I'll give you a second. Make sure you tell the people that aren't here today how much they'll have to work at this unit for what they've missed. Okay. How'd you do?
Literally left. He left the world.
Actually, I will try to explode your mind a little bit today. Okay. We're taking it easy so far. Definitions are okay. Adding and subtracting matrices. Oh, I'm going to make this more exciting. Here we go. Don't look at your notes. We're going to. Oh, it's not working. It's not working. Okay. Here we go. Okay, I hid the strategy. Somehow you have to figure out what's going on. I have that matrix, that square matrix plus the other square matrix, and look at the answer matrix. There's a lot of numbers there, but there is a pattern that's happening. And the hint, this is called adding matrices. All right, I'm not going to give you any more hints at this moment. Hands up if you think you found it. And that's a confident hand up this time. I'll let you explain it again. What do you do?
Okay, so you take like the ones that are in the same position.
The ones in the same, like you mean like
Yeah,
this
yeah,
one
like
and
that one and
this
that
one,
one, and then
or like, let's do one that's a little bit more exciting, like this one and this one. Okay.
you put them in the big box.
Yeah.
And you like add them together.
So 1 plus 0. That's how you got this one.
Yes.
Brilliant. And the 2 plus. That's how you got this 3.
Yes.
And that works for all of them.
Yes.
Oh my goodness. The matrix expert at the back figured this out without
Escape the matrix.
any, like, this is not like, you know how sometimes they have things like at magic shows that are set up. I want to make it known, I did not talk to him before class and say I need you to come through for me.
True, and you know that because I was late.
So it says we add two that have the same order, but let's say we have a 2 by 2 matrix, and then a 1 by 4. They have
Yes,
the same order, but not the same shape.
that's right. So if you had two things that were different shapes, you're just not allowed to add them. Life is easy.
Wait. What if they're similar shape? Like, what if they're similar dimensions? They're just inverse. But could you do the thing? With
We want to keep life easy.
But could you transpose them?
You could add one and a transpose of the other, then get an answer if they match up. So if the dimensions,
So if it's like 3 by
they have
4,
to have the same dimensions exactly.
okay.
If there's another, like, life is easy, different dimensions, you just can't do it, right? That was never an answer, right? Wouldn't that be nice on multiple choice for the AP Calculus exam? They give you this tough question, and one of the options is, I actually can't do this one, which would be the true answer. I don't know how to solve this. They might give you the right answer as well, but it is an option to say, I don't know how to do this, and you actually don't. Yeah, so life is easy. Whew. Multiplying by a number in front. Oh, should I hide it? I didn't hide it. You saw it ahead of time. But if I had hidden this, and you had this and the answer,
Dane, what do we do?
you want to explain it again?
Yeah.
Okay, let's
So you take the number outside,
the number outside.
yeah?
Yeah.
And you multiply it by every number.
So sort of like
Individually.
I could put like the arrows, think of like distribution almost like this, right?
Yeah, that's like another buzzword.
And does it work? Look
Yes.
at 2 times 8, I'm gonna just go, it is 16. Yes. So a number out in front. And it kind of makes sense because 2 of something would be like adding 1 plus the other. That would work too, because the 8 plus the 8 gets me to 16 as well. Oh. Life is good. All right. Take out your graphing calculators, because you're going to need them for this next part. Find the matrix button and enter these 3 into your calculator. So I'll help you out with this. There's Do you see the matrix button above right here at this X inverse?
Yeah.
Right above it? So if I go second matrix, I've got already matrix A, B, C, D. And if I go over to edit, that was cool. No, I can't do it again. That was okay. I don't know what. So, if you go over to edit and you push enter, it says how big of a matrix do you want to make? Well, how big was our A? Our A was a 2 by 2, so I go 2, enter, 2, enter, and then we can enter in the numbers that we have. 1026. 1. When you push enter, jumps to the next one. 0 jumps to the next one. 2 jumps to the next one. 6. Go. And then I can go second matrix, go over to edit, and notice in A it now lists it as a 2 by 2. I can go to B, and how big was B? B was 2 rows, 3 columns, 2 by 3. 2 by 3. And then it was -1, -1. Make sure you use the negative sign. -1, -1, 2. What were my next 3 numbers? 2, 0, -3. Oh, I wrote it in wrong, didn't I? 2, -1, -1. Oh my goodness. 2, -1. -1. And then 2, 0, -3. 2, 0. Oh no. Perfect. And now one more. Second matrix. Go over to edit. And C is the 3 by 2. It's kind of nice that if you accidentally made the wrong dimensions, you would see it and see that it was wrong. Okay. So now you can do matrix math, like if your mental math wasn't there for you that day, you could go second matrix, click A, plus second matrix, click A again, and A plus A, did it work? 2, 0, 4, 12? All right. So, life that was good is about to change. I'm so sorry. I've led you on this path.